Okay, so good day everyone. Our topic is all about the introduction to statistics or fundamentals of statistics. Okay, first we have to know what, when, where, how, and why of statistics. So first is what are statistics? Statistics are procedures that combine, organize, and summarize data to make inferences. So, scientists collect data to generate and test theories and hypotheses, but the data that are initially unorganized and raw, and statistics allow one to organize the raw data into something condensed and more meaningful. That's why there is a big difference between data and information. You have to remember that data, these are the raw facts, and information, these are the processed data. So, statistics are used just about everywhere in most occupations. Understanding statistics, including where they are used, why they are used, what they represent, how to interpret them, and how to properly use them, is an important part of being an informed citizen. Understanding statistics allows you to understand facts and figures presented in the media and in other college courses, and allows you to be a little more skeptical about information when it is presented. And if you don't know how to question information, it is unlikely that you ever will. So, if statistics had not been invented, we could complain about Congress, the president, and the Supreme Court, but could not describe how much we generally approve or disapprove of their performances. If we did not have statistics, we would not know how many people accept evolution or don't. If we did not have statistics, we could not determine how much better one sports team performed relative to other teams to determine playoff standings. And without statistics, of course, we could not confirm myths about the relationship between the sizes of various body parts. Okay, so when are statistics used? Statistics are used whenever you are trying to answer a question that requires summarizing data. So, for example, let's say I hypothesize that age is related to political attitude or the liberal conservative. So, specifically, older individuals tend to be more conservative. One way to address this would be to ask people of their age and their political attitude on a liberal conservative scale. Then, based on the data I collect, and I can determine whether there is a relationship between the age and political attitude. So, a set of hypothetical data listing ages and political attitudes of people is presented here. So, political attitude was measured using an 11-point scale from 1 is equal to liberal to 11 is equal to conservative. So, you can see that as age increases, political attitudes tend to become more conservative, although the data appear to support hypothesis. The only way to know whether a relationship exists is through a statistical analysis. Okay, so where are statistics found? So, statistics are not only used by scientists, all professions use them. You have the businesses, teachers, schools, sports, government, the military, the justice system, religions, and social organizations in their use statistics in their own ways. So, for example, at the end of the 2007 Major League Baseball season, the batting average or AVG of Derek Jeter was .32, which means he hit a pitched ball and made it safely to base about 32.2% of the times he made a plate appearance. So, this value is a type of statistics that players, teams, sports writers, and fans use to gauge how well a player is performing. Okay, so we use statistics when we want to collect data, when we want to analyze data, if we want to have a solution creation and also solution presentation, and lastly, solution application and maintenance. Okay, so why do I need statistics? Bakit nga ba natin kailangan ng statistics? You need to understand statistics in order to understand most scientific research. So, if you take a research methods course in the future, your instructor or professor will use a lot of data analysis examples. Second, statistics are used to explain topics in upper level psychology courses, especially for more empirically based courses like the sensation and perception. We also have the cognition, conditioning and learning, social psychology, and courses in neuroscience. So, and third is statistics allows you to understand information presented in the media. So you always hear percentages and proportions of people that agree or disagree with some topic. So if you know something about statistics, you will be able to understand. Also, knowing statistics allows you to judge for yourself whether something in the popular media makes sense or not. Okay, so statistics as a language. Statistics is best understood at a conceptual level, just like any language. So when you learn a new language, you don't focus only on new words in isolation. You relate to new words to the words you know in your native language. So the difficult part to statistics is you will see these basic mathematical concepts in new and different ways, and this is where students get into trouble. So students tend to focus solely on each term in each formula but fail to integrate concepts to comprehend the overall meaning statistical procedures. So for example, when you read a word corruption and try to retrieve the meaning of that word from your mental dictionary, you don't focus on each letter in the word, just like the CORRUPTION to retrieve its meaning. Rather, you focus on the entire word. So the same is true in statistics. Don't focus on the small pieces of formulas and the numbers. but you focus on the language and on the big picture. So if you do this, the little pieces and the numbers fall into place. So also because you will likely be reading research sports, articles, and textbooks that include statistics, and you need to learn the language of statistics. So, for example, when you see the standard deviation of 12.558 seconds, you need to know how to interpret this statistically. So there is a language to statistics that you will learn to comprehend. Okay, now we have two types of statistics. So first is the descriptive statistics. These are used to consolidate data into single representative values that can be used to describe the entire set of data. So take the following set of data. So you have the 3, 4, 6, 7, 3, 4, 5, and 8. You might take the average of these scores, which is the average of 5, and use the average to represent the data set. And as another example, you might have the following data. So you have the 7 of 8 and use 7 as a representative value because 7 is the only value in the data. Okay, next is the inferential statistics. A statistical test used to analyze relationships between variables, and this type of statistics allows us to make inferences and assumptions about the data we collect relative to some larger group that was want to know something about. So in here, we cannot collect data on very large groups because often we don't know the size of a group, so we collect data from smaller samples and use that data to make inferences about what we would likely to find in the larger group. So this is using statistics to make inferences, hence inferential statistics. Okay. Then we have variables. So variables is anything that can change or take on different forms. So variables are often labeled with an uppercase letter such as X or Y. So for example, if I measure political attitudes, I might use X to denote the values for the variable political attitude. Okay, so we have here examples of variables. You have the blood pressure is a variable because it can vary across people and vary across time for a single person. We also have the sex or gender. It is also a variable because it differs across people. And the political attitude because some people are liberals and some people are conservatives. So we have independent variables. These are anything that is being measured. So dependent variables are within the operational definition for a hypothetical construct. So if we define memory as the number of words recalled from a list of 100 words studied 24 hours earlier, so the number of words recalled is the dependent variable of memory. And we also have the independent variables. anything that can change or differ between situations or groups that can influence a dependent variable. So, independent variables can be something that differs naturally between groups or situations. So, for example, biological sex, we have male versus female, and independent variables can also be directly manipulated across groups or situations. Now, we have here an example. So, for example, I am interested in the influence of noise on studying. I assign one group of 10 students to study between 7 p.m. to 8 p.m. each night while I play loud music, and a second group of 10 students to study during the same time. But without music, I manipulated noise between the two groups. So, to examine the influence of noise on studying, I could compare exam scores on the studied material between groups. So, if the manipulation of noise influence studying as measured by the exam scores, I might expect the results below. So, you have here the noisy, we have the 70% correct, and the quiet, we have 85% correct. So, you can see the change in the independent variable, which is noisy versus quiet. It was associated with a change in the dependent variable, that is the percentage of the correct. So before I conclude the difference in the percentage of correct was due to the noise, I must use inferential statistics because it is possible this difference happened by coincidence. Okay. Next is quantity versus quality. Quantitative variable includes numbers as levels. So a quantitative variable is one where levels of the variable are numerical and can be used to express differences in amounts of ratios. So examples are height, age, the GPA, temperature, salary, length, and etc. And for the qualitative variable or categorical variable is not quantitative, and the levels include distinct categories. So qualitative variable do not have much numerical meanings attached to their levels. So data collected from qualitative variables cannot express differences in amounts or ratios, but can express differences in types. So example, we have biological sex, male versus female. We also have the hair color, the college major, college class, race, political orientation, national affiliation. So qualitative variables may be disguised as quantitative variables. So one example is in digital files. Example, we have the Excel, the SPSS, and the R, where the levels of the variable sex may be entered as 1 or male for male, 1 for male, and 0 for female. Okay. So, hypothesis and predictions. Everything statistics are used mainly to evaluate research questions. So, when a researcher has a question, he or she designs a study that collects data and applies appropriate statistical procedures to determine whether the data support his or her question. Okay. So we have here an example. Okay, so to measure the performance of the program for international student assessment test scores. Okay, so say I am interested in the relationship between wealth inequality as measured by the Gini coefficient and performance on mathematics test. So the Gini coefficient is a measure of national wealth inequality and is calculated by many organizations around the world, where a value of 0 indicates complete equality and 1 or 100% indicates complete inequality. Now there are two hypotheses we must generate. So a null hypothesis or the HO and the alternate hypothesis or the H1. Each includes a specific prediction about what might be found when data are collected, but the null hypothesis predicts the research question will not be supported by the data. So it predicts no relationship would be found between wealth inequality and mathematics test performance. So, in contrast, the alternate hypothesis predicts a research question will be supported by the data. So, it predicts a relationship will be observed between wealth inequality and mathematics test performance. So, the two hypotheses make opposing predictions. The null predicts no difference on the dependent variable or no relationship, whereas the alternate predicts a difference in the dependent variable or a relationship. So, do you think there is a relationship between wealth inequality and math test performance or not? So, if there is, does this seem to support the null hypothesis or the alternate hypothesis? Okay, moving on, we have the samples, populations, and samples. So, a population includes all members of that target group, and the number of people in that population is usually labeled with an uppercase N. So, researchers make inferences about populations, so they need to be sure to collect data from the correct population. For example, you might conduct research on depression, but the people with whom you conduct the research were only males between the ages of 20 and 25 with mild depression. In this case, you cannot make inferences about all people with depression. Rather, you make inferences only about males between the ages of 20 to 25 with mild depression. So it is critical to have research participants reflect in your intended target. Okay. So instead of collecting data from populations, researchers rely on samples of populations. While samples being smaller, representative groups selected from the population. As long as the sample is representative of the population, a researcher can use the data collected from the sample to make inferences about what would likely be found in the population. That is, as long as individual differences from a population are equally represented in a sample, a researcher can make conclusions about what would be found in the population based on what is found in the population. Next, we have the sampling. So, the main issue with samples is whether they are representative of a population, whether the subjects in the sample accurately reflect the subjects of the population. So, the best way to ensure a representative sample is through random sampling that involves selecting people from a population that at random and without bias. Okay, so for example, if I were to select a base some random sample of baseball players for a sample, I might assign each major league baseball player a number and randomly select 10 of those numbers, with the 10 selected players becoming part of my sample. So this occurs when you get too many individuals from a certain subgroup within a population into your sample. For example, you get too many males or too many females in a sample, or too many people with a high IQ. Unfortunately, it is difficult to detect this, and the only way to ensure a sample is representative is measure people in the sample on relevant variables and check. That is why we have here the downside to sampling is occasionally, and even with random sampling, a sample becomes biased and not representative of the population. Okay, so we have the random selection. When creating a sample, the most important thing is the sample must be representative of the population. This means that individual differences among subjects in the population are represented proportionally in the sample. So, what we mean by represented proportionally is large subgroups within a population have more subjects in a sample relative to smaller subgroups within the population. Okay, so for example, we have here an example. Say I have the following population of red and blue letters of X and 0, and I need to create sample of N is equal to 10 from this population. Assume there are equal numbers of red and blue, X's and O's in the population. So we have a population of 10 for each group in here. So we have here the graphic representation of the population. Okay. Okay. So the first step to random sampling is to assign each potential subject a number. In this case, I'll just use 1 to 40. 1 to 40, which I have placed as subscripts as presented. And next, using a random number generator, I generate a set of 10 random numbers because I need a sample of 10. Assume I obtain the following set of 10 randomly generated numbers. So I took the 1, x1, x3, x10, o16, o18, blue x22, blue x21, blue x22, blue 034, blue 038, and blue 040. So subjects with these numbers are placed into my sample. Random selection attempts to have each subgroup within a population be represented proportionally within a sample. In this case, it would mean having equal numbers of red O's, blue X's, and blue O's in the sample. Indeed, you can see in the slide there are appropriately approximately equal numbers of red X's and O's, blue X's, and blue O's in the sample. So the sample is fairly represented of the population. Okay, so suppose this is our population and we want to determine a good sample. So on the left box um we have the red, the pink, green, orange, yellow, and blue balls. Now on the other box we have chosen the 9 population of yellow, and this is a bad sample of population because the population is not all yellow. Okay, we also have another bad sample of population, though there are more colors, it does not have all the colors. So we still have the pink and also the red, which is not included in the sample that we've chose. Okay, this is also a bad sample because there's too much green on it. Hindi balance yung kinuha natin na sample. Okay, so we have here a better sample. So a good sample should be large enough, the computations are available and unbiased. Okay, so now we assume each ball has a different characteristic in weight, size, scent, and cost. Okay. Okay, for the random sampling, all elements have an equal chance of being selected. Each observation is chosen at random. And we also have the stratified sampling, selection per strata or per classification, useful when there is a great variability between subgroups. So we took two red, two pink, two green, two orange, two yellow, and two blue uh, samples. We also have the cluster sampling, selection as a group, useful when there is not much variability between subgroups. Okay. Research designs and statistics. So correlational designs are used when research question is asking whether there is a statistical association between two quantitative dependent variables. Correlation designs do not include independent variables, only dependent variables. You have to take note of that. Because no independent variables are included and you cannot make cause and effect relationships. So for example, is there a statistical association between SAT scores and a freshman year GPA? So it's a research question that could be answered with a correlational design. You could randomly select a sample of freshman students who have taken the SAT. You would obtain their SAT scores and take and their GPA at the end of freshman year. Through one of several statistical procedures, you could see if the SAT scores are related to the GPAs, and that is, did students who scores higher on the SATs tend receive higher GPAs. Okay. In experimental design, a researcher directly manipulates one or more independent variables and measures at least one dependent variable. So, the aim of experimental design is to see if the manipulation of the independent variable is associated with changes in the dependent variable. Okay. For example, the sex, male versus female, is an independent variable that cannot be manipulated because a subject naturally falls into one of the two levels. Because the independent variable is not being manipulated, a researcher cannot establish cause effect relationships. Rather, the researcher can only establish group differences. And we also have the quasi-experimental designs, which are used when the research question is whether there is a difference in performance between two or more pre-existing groups of subjects. Okay, so computers and statistics. Now, there are a variety of computer programs that allows you to perform a statistical analysis and procedures on a set of data. So we have the SPSS or the PASW. We also have the Minitab, the SAS, the R, MATLAB, and of course the Microsoft Excel. So indeed, all of the procedures that we will cover in this course or subject can be performed using software, but we'll be using the Microsoft Excel. So the simple explanation is you need a foundational knowledge of what the various statistics you will encounter represent, what they measure, what come from, and how they are calculated. Okay, so that ends our discussion and thank you.